Like yesterday, I'm gonna say?
Yep, your hair is right.
Yes.
I've never done your hair.
Yeah, I wish I was doing the jig.
No, I'm talking like the top 1%.
Okay, hang on.
Your dad needs to go get dirty.
But we can't start yet, I really need my brush.
Like Jacob, I don't need to go.
I wouldn't want to.
I don't think the milk.
Hey, guys, check out my Snap this weekend. You gotta watch my Snap
Yeah,
story
we
this
like to have
weekend.
fun.
I'm meeting Travis Scott and Uzi Vert and everybody.
Where you
We're
going?
lit.
Oh, here it is.
Okay, let's get going.
This one.
There's a Josh Turner out there in Burnett.
I'm emotionally unstable today.
You like country? Grab you for you with a fire rock.
But I'm just saying.
Wanna go? I don't like country that much.
Wait, you're going too fast.
Yeah, me too. I
Okay.
don't have my notebook out yet.
That's not my problem.
I had to find a picture. It was concerned.
Ask people over there if they're caught up to me. They're waiting.
Because that's.
Okay, that
No.
they don't talk.
They count.
They don't count.
You need to take notes from over there.
But maybe we should do that today, take notes of
Yeah.
them.
Okay. Given a linear regression equation, the y hat equaling mx plus b, and you will be doing everything by hand tomorrow, and I'll be checking the work by hand, but you do have the technology to make sure you're coming up with the right stuff, because everything we did by hand can be done by technology except for that SE. That's got to all be done by hand. So given this linear equation and an x value, so normally we would just say, well, if x is this, we plug it in and we get the corresponding y. We expect it to be on the trend line. Well, the chances of that y value actually being on the trend line are pretty slim. So what we're going to find, and I'll show it in a picture, is a range of values that we expect the y value to be in. And I'll write that down in a minute. So we call it a C prediction interval, C for confidence. So, first want to explain what I tried to say there in words with a picture. So you have your scatter plot, you calculate your trend line, you draw it in, and you know you can use your trend line to make predictions. So for a given x value, which they call x sub 0, normally we would just say, well, if x is this value, then the y value we expect to be whatever the trend line says it's going to be. Well, the chances of it actually being that one value are pretty slim. So what we're going to do is give a range of vertical values here. Could be anything in between this lower y value to this upper y value. Let's say 90% confidence, we'd have an interval. 99, we're going to make it a little wider. 80%, we'd make it narrower. So we're going to be finding this range of values that we expect y to fall in between for a given x. That's what we're doing. So instead of picking one value, we're going to give a range, because if I have a range of values, chances are I'm going to get it right, instead of just picking one number and trying to match it. So how do we do that? Well, you figure, you take your x number, plug it in, get your y hat. Then we're going to add and subtract this max error, big E. And big E is quite a challenge. So, here's how we get big E. Here's where the work comes in. We're going to use the t-score for the given confidence level. So they'll tell us 90% or 99 or 95, and we look up the t-value for it. You multiply that by the standard error from yesterday. Then you multiply that by a very obnoxious square root. 1 plus 1 over n plus the fraction n times xo minus x bar squared, just that part divided by n times the sum of x squared minus the sum of x squared. And our degrees of freedom, when we read the t-table, remember we always need degrees of freedom. And because we've got two variables working, the x and the y, it's n minus 2. Okay, we're going to go through one full problem. Are you ready? This is it. It will take us time. Okay, so the one we're going to do is out of the book. Is number 20 on page 450. And we'll go to that in a minute. I want to look at this formula. Just make a list of all of the values that I need to plug in here. So we need the t-score for our confidence level. We need to figure out the SE like we did yesterday. We need N. We need XO. We need X bar. We need the sum of the X squared. And we need the sum of the X so that we can square it. Okay, before we even look at the problem, let's find the t-value. Oh, I got to need the problem. We need to know what confidence level we're doing. So page 450. It's almost done. 450, number 22. No, 20, I said. Okay, use the results of exercise 12, so we'll be going back to 12. We're going to construct a 90% prediction interval for the median number of leisure hours per week when the median number of hours worked hours per week is 45.1. So this 45.1 is our XO value. That's what we're going to be plugging back into our scatter plot. Okay, our confidence level is 90%, but we've got to go back to 12 to see how many data points we were using. And 12 has how many data points in it? 8? 2, 3, 4, nope, 10. So, DF is going to be 10 minus 2, or 8. And then the confidence level, what did I say, was 90%? Yep, 90%. So use your table. Remember, confidence levels are at the bottom of the t-table. So grab your t-table. I don't have mine anymore. It's buried on my desk somewhere. Oh, maybe here. Oh, look at that. So we have 8 degrees of freedom, and the confidence levels are down here. We're doing 90%. 1.860. So our t-value is 1.860. N is 10. And now we've got to go back and do yesterday's SE, that standard error. That's where most of the work is going to come into play. And remember, we need 4 lists for that. And we're not going to write them all down. We're just going to do first and last like we did in the homework. It's right in the problem 20. It says it at the end. So we're going to go L1. Yep. L1, L2, L3, L4, and then we're going to find SE after all that. So as far as writing on paper, L1, we're going to start with our X's. This will be 40.6. Last one's going to be 50.8. L2, 26.2. And 19.5. Okay, and the rest we're going to have to type them all in to get the rest of the stuff. So I've already got mine in from second hour, so I'll give you a chance to put all your X's in list 1, all your Y's in list 2, and then we'll move through this whole process again.
From number 12.
Yep, so we've got to find the SE from 12 before we can go do the confidence interval from 20. And I'm not going to bother writing in all the middle ones, just the first and last. That's plenty for me to know what's going on. And same thing tomorrow, just make the by hand. When I say by hand, this is all I want, is the 2 rows. And I'll clear out 3 and 4. You can tell me where those come from when you're ready. Are we ready for list 3 yet? Yes. Where does list 3 come from again? The equation. We want all of the x values substituted into the trend line and then crank out all of the y values here. So the way we do that is because they give us the equation. If they didn't give us the equation and you had to use technology, where do you get this equation from? Linear regression L1 comma L2. Okay. So we're going to type in negative 0.646 times L1 plus 50.734 up on top. Oops, 50. Okay, I got 24.506. Let me know if I'm different, if I hit something wrong. And then on the bottom I got 17.917. Okay, good. Where does list 4 come from?
L2 minus L3.
L2 minus L3, we're going to subtract those y values. So over here, 2 minus L3. 1.6936.
You can do round before that.
Yep. I think the book's consistent with 3 decimal places, it seems like, in this section. 1.5828. Okay, now the SE formula from yesterday. It was a square root of, remember where the numerator came from. It was the sum of the y's subtracted and squared over n minus 2. What do I do to get this numerator? Where does that come from? L4. We're going to do 1 var stats on L4. Do you remember that? 1 var stats on L4, and we're going to take the sum of the x squared. So if we quit, 1 var stats on L4, 32.419. N minus 2 is going to be 8, and then we'll square root that. Yep. Okay, so we got our SE figured out, 2.013. So 2.013. Okay, now I need to know x bar. Where do I get x bar from? What does that mean, x bar? 1 var stats on which list? List 1. It's the sum of, or the average of the x's. So 1 var stats list 1. X bar is 47.55. Where do I get the sum of the x squareds? Right there. It's that third line down. 22,716.29. And then the sum of the x is also right there. 475.5. Okay, got all our values. Now we got to plug, and then a whole lot of junk. Okay. So looking at the big E formula, see if I can get it on here. I can. So to calculate big E, and then we still have to go back after we get big E, come back up and do the interval. So we'll find big E first though. Okay, the t-score we said was 1.86. SE 2.013. Square root 1 plus 1/10. 10. XO. XO was the where we were doing our prediction, the X value that we were doing the prediction interval for, and that was given in problem 20 as 45.1. So that's always a given value, you don't have to find that. Minus X bar squared 10 and then 22,716.29 minus 475.5 squared. I personally would not do this in one line, but it can be done. They challenged themselves in the second hour. I would start here with this fraction, work that out, get a decimal, add on this, do the square root, multiply, multiply. So I would definitely be doing it in about 5 lines on the calculator. But you try it, and then I will show you what I would do. Definitely calculator challenging.
So what if we do parts of it right down? What should we round to?
3 places out we'll go. The book's been consistent on 3 places out with everything. Here. So it should be good enough if you go 3 out on your... But you can do it all in the calculator in pieces and not have to write anything down, is what I'm saying. Don't want to do that? Okay. I will show you after. What is the answer? 4.026 is the got that?
Yeah.
Nice. Got 1, 2, 3.
What is it?
4.026. No.
That's just 2.0 in your equation, or 2.0?
13. It's our E,
Oh,
SE.
I see.
2.013. Okay, anybody else want me to go run through it? Lizzie's trying it again. She's trying for round 2. Nope. Okay, I'm going to show you what I would do. First off, you've got a fraction here, so I'm going to use parentheses to do that whole fraction. You don't really need them on the top because everything's multiplied, but it's not going to hurt to say I'm going to put parentheses around my numerator and parentheses around the denominator. So I'm not going to write anything down until I get to my answer. Is that TV on? Yeah. Okay. So I got 10 times 45.1 minus 47.55 squared. Close my numerator. Divide. Denominator start. 10 times 22,716 minus 475.5 squared. Close my denominator. There's my fraction. I'm going to add 1/10, add 1. Now I'm going to square root that, times by 2.013, times by 1.86. So, whatever it takes to get there. All right. So there's our error. What I need now is when x is 45.1, what's my y hat value? Well, I got to go to the y hat equation that they give me. Plug in 45.1 1. So the y hat value at 45.1 is so the y value would be negative 0.646 times 45.1. 21.599.
Wait, is that supposed to be 45.1?
Oh, yep. I typed it in right, I just didn't write it down right. 21.599. So that would be our prediction for landing right on the trend line. But to get a better estimate, we're going to give that interval of 21.599 plus and minus that 4.026. So we are 90% confident that the y value will fall between whatever we get when we subtract.
Can we have like one over problem?
You get 2. So we're 90% confident that the y value would fall between those two numbers. Okay, you get to do, what was it? 22 and, let's see, page 451, 22 and 24, and they both refer back to a problem earlier, 14 and 16. Right there. So 22 and 24 ask for the confidence interval for the y value, but you got to go back to 14 and 16 to calculate the SE first. So it's 2 problems referring back to 14 and 16.